Imagine drifting through the infinite expanse of the cosmos, where time flows differently and every star, every galaxy, and every distant nebula holds a secret waiting to be uncovered. In this vast universe, some things remain frozen in time, relics from the past that have been untouched by the cosmic evolution we see around us today. One such discovery, made possible by the James Webb Space Telescope, JWST, has stunned astronomers and brought us face to face with a living fossil of the universe, an ancient galaxy that has been frozen for billions of years. This fossil galaxy, unlike most galaxies we know, has not formed any new stars in eons. It's a time capsule from the early universe, offering us a glimpse into a cosmic past that challenges everything we thought we knew about galaxy evolution. Now, this might sound like a scene straight out of a science fiction movie. A galaxy, floating through space, untouched by the cosmic cycle of birth and death that governs most celestial bodies. But this is not fiction, it's a discovery that could reshape our understanding of the universe itself. For billions of years, stars have been born, lived, and died in the cosmos. Galaxies grow and evolve, constantly forming new stars, collapsing, merging, and undergoing dramatic changes. But some galaxies, like the fossil system recently discovered by the JWST, have stopped forming new stars so early in their history that they've become relics of the universe's infancy. These ancient systems don't evolve the way most others do. Instead, they remain largely unchanged, offering us a snapshot of a time when the universe was still young. The James Webb Space Telescope has opened up new frontiers in our quest to understand the universe. With its extraordinary infrared capabilities, the JWST allows us to peer deeper into space, and further back in time, than ever before. In fact, the discovery of these fossil galaxies, some of which date back to just a few 100 million years after the Big Bang, is one of the many marvels that JWST has brought to light. By studying these ancient relics, scientists can learn about the conditions of the early universe and the processes that shaped the galaxies we see today. But the mysteries surrounding fossil galaxies like NGC 1277, the one discovered by the JWST, is not just about their age or how they were formed. It's about why these galaxies, unlike most others, stopped forming stars so early in their evolution. What forces, cosmic or otherwise, caused them to freeze in time? What lessons do these ancient relics hold about the early universe, and, perhaps more importantly, what do they tell us about the forces that govern the evolution of galaxies? Fossil galaxies, such as NGC 1277, offer scientists a glimpse into a time when the universe was much younger. NGC 1277, located about 220 million light-years from Earth, is a perfect example of what we call a fossil system. It is a galaxy that contains nearly only old stars, some of which are up to 12 billion years old, and has not formed any new stars for an incredibly long time. In fact, this galaxy has remained practically unchanged for billions of years. Most galaxies evolve continuously, forming new stars, merging with other galaxies, and going through various stages of development. However, NGC 1277 and other fossil galaxies appear to have stalled in their evolution very early on. The big question that arises is, why did this happen? Why did this galaxy, and others like it, stop forming new stars while most other galaxies continued their cosmic evolution? And why are these galaxies still so dynamic in their own way, despite their lack of new star formation? In the case of NGC 1277, astronomers believe that it went through a starburst event very early in its history. A starburst is a period of rapid star formation, where a galaxy creates an unusually large number of stars in a short period of time. In the case of NGC 1277, this starburst led to the creation of billions of stars, many of which are still alive today. But after this intense period of star formation, something strange happened. The galaxy stopped producing new stars, and its evolution came to a halt. This frozen state could be the result of various cosmic forces, including the effects of dark matter and dark energy, mysterious forces that still remain largely unexplained by modern science. The interactions between visible matter, and dark energy are believed to play a key role in the formation and evolution of galaxies. The fact that NGC 1277 and other fossil galaxies have stopped forming stars suggests that something in the early universe triggered a dramatic change in their evolutionary path. Understanding what caused this cosmic freeze could provide crucial insights into the larger forces at play in the universe. The discovery of NGC 1277 raises even more intriguing questions. This galaxy doesn't sit at the center of a massive galaxy cluster, as many fossil galaxies do. Instead, it resides in a more isolated region of space, where there are relatively few other galaxies. This isolation makes it even more fascinating, as it provides scientists with an opportunity to study a fossil galaxy in a relatively undisturbed environment. There's no nearby galactic activity to cloud our view or complicate our understanding of how this galaxy evolved. NGC 1277 is, in many ways, a pristine example of an ancient galaxy that has remained largely unchanged for billions of years. The James Webb Space Telescope's discovery of NGC 1277 has also provided a fascinating insight into the black hole at the center of the galaxy. This black hole is an absolute giant, making up around 14% of the total mass of the galaxy. This is an unusually high percentage compared to other galaxies, where the central black hole typically represents a much smaller fraction of the galaxy's mass. Normally, a massive black hole would consume more and more matter over time, leading to the eventual shrinking of the galaxy. But this hasn't happened in NGC 1277. Despite the presence of this enormous black hole, the galaxy has not continued to shrink or collapse in on itself. Instead, it has remained stable, with its structure largely unchanged over the course of billions of years. What keeps this galaxy intact despite the gravitational forces of the black hole? And what does the large mass of the black hole tell us about the formation and evolution of galaxies in the early universe? One of the most exciting aspects of the James Webb Space Telescope's ability to study fossil galaxies like NGC 1277 is the telescope's ability to peer through thick layers of cosmic dust. Many of the most interesting phenomena in the universe are hidden behind thick clouds of gas and dust, which can obscure our view. But infrared light, which JWST is designed to capture, can pass through this dust, allowing scientists to study objects that would otherwise be invisible to our eyes. With the help of JWST's incredible sensitivity, astronomers can see the hidden structures of distant galaxies, uncovering secrets that were once out of reach. Thanks to JWST's unique ability to observe the universe in infrared wavelengths, astronomers are also able to study some of the most distant objects ever discovered. One such discovery is the Einstein Ring, a phenomenon predicted by Albert Einstein over a century ago but never before directly observed. An Einstein ring is a cosmic optical illusion created by the gravitational lensing effect. When light from a distant galaxy passes through a massive galaxy cluster, the gravity of the cluster bends the light, creating a ring-like shape. This process can also magnify objects behind the cluster, allowing astronomers to observe galaxies and other objects that would otherwise be too far away or too faint to detect. The James Webb Space Telescope has captured stunning images of Einstein rings, including one around the galaxy SDSS J1226+2149. This phenomenon allows astronomers to study distant galaxies in much greater detail than ever before, giving them the opportunity to learn about the structure and evolution of galaxies that are billions of light-years away. Einstein rings are also valuable tools for studying dark matter, as they provide insights into the distribution of mass in galaxy clusters and the way that mass warps space-time. Without the gravitational lensing effect, these distant galaxies would remain invisible to us. But the James Webb Space Telescope doesn't just reveal distant galaxies and black holes. It also allows us to study some of the most distant stars ever observed. One such star is located in the galaxy MAX J1149+2223, about 9 billion light-years from Earth. This star, known as focal point star 1, was discovered using gravitational lensing. The light from this star was magnified by a massive galaxy cluster lying between the star and Earth, making it possible to study the star in greater detail than would otherwise be possible. This discovery marks a significant milestone in our ability to study individual stars in the distant universe, providing valuable insights into the life cycles of stars and their evolution over billions of years. The James Webb Space Telescope is only beginning to reveal the many mysteries of the universe. With its unprecedented ability to capture infrared light, it is helping scientists uncover secrets that have been hidden for billions of years. Whether it's studying fossil galaxies like NGC 1277, observing the formation of stars and galaxies, or examining the cosmic lensing effect of Einstein rings, the discoveries made by JWST are changing our understanding of the universe. These discoveries are not just scientific milestones, they are the key to unlocking the deepest mysteries of the cosmos. In the coming years, as the James Webb Space Telescope continues to explore the far reaches of the universe, we can expect even more groundbreaking discoveries. The telescope's ability to observe the most distant and ancient objects in the universe will undoubtedly lead to new insights into the origins of galaxies, stars, and even the fundamental forces that govern the cosmos. For anyone with a curiosity about the universe, the next few years promise to be an exciting time. The universe is vast and filled with mysteries, and thanks to the James Webb Space Telescope, we're just beginning to uncover its secrets. Whether it's investigating the formation of galaxies, studying ancient relics like fossil systems, or unraveling the mysteries of dark matter and dark energy, one thing is certain: we are on the verge of a new era in our understanding of the cosmos. And the best part is, we're just getting started.